everyone, I am Kirtana. Welcome to online plus 2 chemistry classes. We have already started the chapter surface chemistry. We studied just an introduction in the previous video. In today's class, we will study about adsorption isotherms. What are the different graphs? The Freundilich adsorption isotherm, about catalysis and different characteristics of catalysis. Let us start our class. First, we are going to study about the factors affecting adsorption. The first factor is the nature of the adsorbent. We studied in the last class what is adsorbent and adsorbate. What the molecules or the species that accumulate on the surface is called the adsorbate, and the surface on which they accumulate is called the adsorbent. Depending upon the nature of the adsorbent and the adsorbate, the extent of adsorption differs. That is the first point. Nature of the adsorbent and nature of the adsorbate, it differs. Next point is the effect of temperature. We studied that in the differences between chemical adsorption and physical adsorption, that the temperature affects. For physical adsorption, we show that at low temperature it is highly favorable, and for chemisorption it is high temperature is highly favorable for chemisorption. We already studied. And the next is the effect of pressure that we will study now. Okay, these are the factors that are affecting the adsorption. Let us look the effect of temperature on adsorption. There are two types of adsorption we studied, that is physisorption and what the next is chemisorption. These are the two types, and let's look how temperature affects. When we draw a graph between x by m and temperature, x by m means the extent of adsorption. The extent of how much the adsorption took place, that is the extent of adsorption versus the temperature. We can see that at low temperature the adsorption is higher and it goes on decreasing with the increase in temperature. At low temperature it is highly adsorbed. The extent of adsorption is inversely proportional to temperature. We can say that as the temperature increases, adsorption decreases. We already studied that in physisorption it is exothermic. So energy is released. So extent of adsorption is inversely proportional to temperature in the case of physisorption. Next, look at the case of chemisorption. What happens? For chemisorption, first it increases and then it decreases. That is, an activation energy EA is needed for chemisorption. An activation energy is needed. Why? Because in chemisorption this strong chemical bond is formed. Strong chemical bond. So activation energy is required. So first it increases with temperature. We can say that what x by m is directly proportional to temperature. In the first cases up to here is directly proportional to temperature, extent of adsorption. So it is called as activated adsorption. We will call chemisorption also as activated adsorption. This is the effect of temperature on physisorption and chemisorption. The important topic that we are now going to study is adsorption isotherms. As the name suggests, isotherm means they are constant temperature graphs. Constant temperature graphs. Constant temperature graphs are called as isotherm. When we draw, or it represents the variation of extent of adsorption, variation of the extent of adsorption with pressure, extent of adsorption versus pressure at constant temperature. This is the definition of what an adsorption isotherm. Variation of the extent of adsorption x by m with the pressure at constant temperature is adsorption isotherm. When we draw the graph between x by m, extent of adsorption and pressure, in the x-axis what we can see, at first the adsorption increases. linearly with pressure, and after an extent at high pressures, it will not change. It will be a constant. At constant temperature, after an extent, the X by M is independent. Extent of adsorption is independent of pressure. When we give high pressures, it will not change. It will be a constant. This is what adsorption isotherm. Now we can study about Freundlich adsorption isotherm. Freundlich is a scientist. Freundlich is a scientist, and he did what? He conducted experiments, and he plotted a graph between X by M and pressure, that is adsorption isotherms at different temperatures. He did the experiments. That is, first he did with 195 Kelvin, then 244. Keeping the temperature constant, he did the experiments. What we can see from this graph? As the temperature increases, the extent of adsorption decreases. 244, he got this curve. And at 273 Kelvin, he got this curve. As the temperature increases, what happens? The extent of adsorption decreases. This is only valid for physical adsorption, okay? And also we studied that physical adsorption can be multi-layered. But this graph is valid only for single layer adsorption. Keep in mind, this is an assumption. It is only valid for single layer adsorption and also valid for physical adsorption only. As the temperature increases, the extent of adsorption decreases. Okay. Students, look. From this Freundlich adsorption isotherm, the scientist found an equation, that is X by M. The extent of adsorption is directly proportional to pressure, but not directly, right? It is directly proportional to pressure raised to 1 by N. 1 by N. Okay, this is what he proposed. That is X by M is equal to a constant K into P raised to 1 by N. It is a constant of adsorption K, okay? Where we can see that 0 less than or equal to 1 by N less than 1. Between 0 and 1, the value of N lies, okay? 1 by N lies. Extent of adsorption is directly proportional to the pressure raised to 1 by N, that is X by M is equal to K, a constant into P raised to 1 by N. 0 less than or equal to 1 by N less than 1. If we give log to both sides, what happens? Let's look. Log X by M is equal to, here, log of what? Kp raised to 1 by N we can write, isn't it? Then if we extend log X by M is equal to log K plus 1 by N log P. Okay, this is the final equation. If we give log, we can write as log X by M is equal to log K plus 1 by N log P. Okay, if we draw a graph with what? This is of the form y is equal to what? Mx plus c. This is mx. Y equal to mx plus c. Okay. So if we plot a graph with log x by m and log p, what we will get? We will get a straight line. Because this equals to the equation of a straight line. We will get a straight line. And if we extrapolate it to this y-axis, what we will get? The slope will be what? Mx, right? 1 by n will be the slope. 1 by m slope is equal to 1 by n. Okay, this is the y-intercept. Okay, this is the y-intercept, and what is y-intercept? Log k. Log k is the y-intercept. Okay, students, When we plot log x by m versus log p, we will get a straight line where the slope is equal to 1 by n. This is very important, okay? Look children, these are both the graphs of the Freundilich, okay? We studied that x by m is proportional to p raised to 1 by n, and when we give log, what we will get? Log x by m is equal to log k plus 1 by n log p, where 1 by n is the slope, log k is the y-intercept. Okay, and we will draw this graph. Here this value we will get log k, this distance. Okay, and the slope will be 1 by n. Now look here. This graph I have already told you. This is the adsorption isotherm at different temperatures. When he did, he got. How the question will come? Look, here it will be T1, T2 and T3. The question will be like, find the order of extent of adsorption. How it will be? When we plot a graph between x by m and pressure, what we studied, as the temperature increases, what happens? Extent of adsorption decreases. So, which will have high extent of adsorption? T1 greater than T2 greater than T3, where T3 is the highest temperature, okay? If three values, T3 will be the highest temperature, then T1. So, T1, the smallest temperature, will give high extent of adsorption. That is what we can infer from this, and like this questions will be asked, okay? Now from this, how the question, numericals will be asked from this area. Like if the slope is given, find the value of 1 by n, and also one graph will be given. Here you will get some values. So what is the value of k? Like this, if slope is given, how can we calculate that slope value? If 10 is the slope, 10 is equal to 1 by n, we can say, where n is equal to 1 by 10. Like this, numericals will come for exam, okay? Now let's look what is the drawback of Freundilich adsorption isotherm. When we plot the graph between x by m versus pressure at constant temperature, what we got? We got like this graph, okay? Isn't it? At constant temperature, we got this graph. What is the failure is that he couldn't explain why the extent of adsorption is independent of pressure at why it is independent of pressure at high temperatures. Students, we were studying about Freundilich adsorption isotherm. Let's look at what's the drawback of that isotherm. When we plot a graph between x by m versus p, we got this graph, right? Or Freundilich got this graph. At constant temperature, this graph is plotted at constant temperature. He failed to explain why at high pressures this x by m is independent of pressure. At high pressures, we can see that it is independent. X by m is independent. So he failed to explain why at high pressures x by m, or the extent of adsorption, is independent of pressure. We can see that at lower pressures there is a linear increase. So at low pressures, we can say at low pressure x by m, or the extent of adsorption, is directly proportional to p raised to 1, we can say, or directly proportional to p, because it linearly increases extent of adsorption. At moderate pressure, what we can say, at moderate pressures, that is this region, we can say a parabolic curve, no, that is x by m is proportional to p raised to 1 by n. This is the case at moderate pressures. And at high pressure, what happens? It is independent. X by m is not depending. X by m independent, or what we can say, x by m is proportional to p raised to 0. that is equal to 1. That is, it is independent of pressure. Extent of adsorption is independent of pressure. Up to here, that is at initial pressures, we can say it is directly proportional to pressure. At moderate, up to here, at moderate pressure, what we can say? It is a parabolic. No, that is, it is directly proportional to pressure raised to 1 by n. At high pressures, it is equal at constant, that is x by m is directly proportional to p raised to 0, that is equal to 1. These are the three conditions we can infer from this graph. So the main drawback of the Freundlich adsorption isotherm is it couldn't explain what is the reason for the behavior of pressure at high pressures. That is why it is independent of pressure at high temperature. Now let's discuss about some of the applications of adsorption. First application is creating vacuum. If we need to create vacuum in a bottle or in any experimental setup, what we can use adsorbents that will adsorb the gases inside it. That is, it helps in creating vacuum. Next application is gas mask. We already studied about gas mask. What it does, it adsorbs certain poisonous gases. In mask, there is what activated charcoal is present that adsorbs the poisonous gases. Next is humidity control. It means if we place silica gel in a corner of a bag or something, if it is wet, it absorbs all the moisture control. So humidity can be controlled with adsorbents. Next is removal of coloring matter. Certain adsorbents have the capacity to adsorb colored matters also. Next is heterogeneous catalysis that we will study later. Separation of inert gases. That is, different gases have different adsorption capacity. Based on the extent of adsorption of different gases, we can separate all gases. That is, separation of inert gases can be done with the help of adsorbents. Next is medicinal purpose. Medicinal purpose means certain medicines, if we intake, what it will does, it will adsorb the bacteria and make it inactive. That is the purpose of adsorbents in medicine. Next application is adsorption indicators. It is also used as adsorption indicators. These are some of the applications, important applications of adsorbents. Creating vacuum, used as gas mask, humidity control, that is moisture control, removing of coloring matter, heterogeneous catalysis, separation of inert gases, medicinal purpose, and as adsorption indicators. Let's discuss some of the questions. This is a previous year JEE question. According to Freundlich adsorption isotherm, which of the following is the correct statement? First statement is x by m is directly proportional to p raised to 0. Second one is x by m is directly proportional to p raised to 1. And the third statement is x by m is proportional to 1 by n. And the last statement is all the above are correct for different ranges of pressure. What is the correct answer? I have already taught you. The correct answer is all the above are correct for different ranges of pressure. We observed that at low temperature it is directly proportional to pressure x by m, and at moderate temperature what we saw, it is directly proportional to x by m is directly proportional to p raised to 1 by n. And at what high pressures what we saw, x by m is directly proportional to p raised to 0. So this D option is the correct answer. All the above are correct for different ranges of pressure. Look at the next question. Which of the following is not correct in the case of physics option? This is the next question. Which is not correct? First statement is adsorption in solids is reversible. Next statement, adsorption increases with increase in temperature. Adsorption is spontaneous and both enthalpy and entropy are negative. Try to answer this question. Which of them is not correct? Look, adsorption in solids is reversible. In the case of adsorption, it is right statement. Okay. Adsorption increases with increase in temperature. What we studied, adsorption decreases with increase in temperature. Remember the graph? Freundilich adsorption isotherm. This is a higher temperature, and as the temperature increases, what happens? The extent of adsorption decreases. Extent of adsorption decreases with temperature. That is, this is the wrong statement. This is not correct statement. Let's look the next statement. Adsorption is spontaneous. It is correct. Both enthalpy and entropy are negative. That we already studied. That is, it is an exothermic process, so enthalpy will be negative. And in the case of entropy, after the adsorption, entropy decreases because disorderness decreases. So other all statements are correct, and adsorption what decreases with the increase in, this is wrong, decreases with increase in temperature. Look at the third question. This is a JEE 2003 question. It's an easy question. Rate of adsorption increases with option A, decrease in temperature, option B, increase in temperature, option C, decreases in pressure, decreases with pressure. And the D is decrease in surface area. Rate of adsorption increases with, we know that the answer is it increases with decrease in temperature. Okay. Next topic of discussion is catalysis. Berzelius, as a scientist in 1835, he said that a substance that alters the rate of a chemical reaction and remains chemically and quantitatively unchanged is called a catalyst. That alters the rate of a chemical reaction and it will remain after the reaction unchanged, chemically and quantitatively unchanged is called a catalyst. And that process which increases the rate of a chemical reaction is called catalysis. Okay. Catalysis is of mainly two types, heterogeneous and homogeneous. Catalysis is of two types. First one is homogeneous. Homogeneous. This means that the reactant and the catalyst are in the same phase. Reactant and the catalyst in the same phase. They are called as homogeneous catalysis. The next category is the heterogeneous. Heterogeneous. If the reactant and catalyst are in the different phase. Next other category or other division is that positive catalyst and negative catalyst. Positive catalyst. What a positive catalyst do? It increases the rate of a reaction. Increases the rate of the reaction. There is also a negative catalyst. Negative catalyst. What it does? It decreases the rate of a chemical reaction. Negative catalyst can be also called as poison. It can be also called as poison. That decreases the rate of a chemical reaction. Let's discuss about some of the characteristics of catalysis or a catalyst. What are the characteristics? First, I told you that it remains unchanged after the completion of a reaction. In composition, it will remain unchanged. At the beginning, what is the concentration? That much you will get after the reaction also. Next is only small amount of catalyst is usually needed for a chemical reaction. And the finely divided catalysts are more efficient. Finely divided means what? Powdered, usually powdered, that has more surface area. So more surface will be available for adsorption. Finely divided catalysts have what? High surface area, so high extent of adsorption will be there. Catalysts are usually specific in nature is the next point. They are highly specific. It cannot initiate or start a reaction. That is an important point. A catalyst will not initiate or start a reaction, but only helps in increasing the rate of that chemical reaction. Next important point is it will not affect the enthalpy, entropy or free energy. Will not affect or it will not be altered. Next is the term optimum temperature. It is a particular temperature at which the action of a catalyst is at its maximum. It is highly efficient at that temperature. That particular temperature is called optimum temperature. Next is important point is the catalyst will not affect the equilibrium of a chemical reaction. It will only provides an alternate path. If the reaction is like this, what a catalyst do? It will only lowers the activation energy. Okay? It will not affect the equilibrium. Starting and ending point will be the same. These are the characteristics of main characteristics of a catalyst. Okay. In today's class, what all we learned? We studied about adsorption isotherms. Studied about the Freundilich adsorption isotherm. That is an important topic in this chapter. What are the equations? When we apply, that is x by m, extent of adsorption is directly proportional to p raised to 1 by n. We studied when we take log, what we will get? Log x by m is equal to log k plus 1 by n log p. Remember both the graphs. At high temperature, the extent of adsorption decreases. We studied. Next, what we studied? We discussed some of the important questions that are related to that topic of adsorption isotherms. It's an important topic. Okay. Next thing we studied about catalysis. What are the different classifications of a catalyst? And now we studied about the characteristics of catalyst. That's all for today. I hope you understood what I have taught you. If you have any doubt, you can comment below. Thank you and have a nice day.